Still in Note 7.1, talking about some exponents. Let's check out some examples. Rewrite each expression below as a single base. So right now we have the same base, but we have it here twice. Since we are multiplying with the same base, we're going to use the product property. So we write the base one time. We take the first exponent and we add it to the second exponent. We're allowed to do this anytime we are multiplying with the same base. 2x plus a negative 4x is a negative 2x. A minus 3 plus a 5 is a plus 2. Finished. This next one, this has the product rule, and then we have the fraction bar, so it's going to be the quotient rule. So on the top, it's the product rule, because we're multiplying with the same base. We're supposed to add the exponents. That's going to be x plus 3x plus 4. In the denominator, we do the same thing. We have the same base. We take the first exponent and add it to the second exponent. So on the top, we're going to get an x plus 3x is 4x plus the constant 4. On the bottom, we have a base of 2. 2x and x is 3x, and a plus 1 and a minus 5 is a minus 4. Now, using the quotient property, we are dividing with the same base, so we write the base one time. We take the top exponent minus the bottom exponent. 4x minus 3x is x. 4 minus a negative 4 is like 4 plus 4, which is 8. There are different orders you could do these things in. Keep that in mind. This is just one such way to do it. All right, the next one, this here is a power to a power property, because we have an exponent to an exponent. So we're supposed to multiply the exponents together. If I distribute the 3, I'm going to get 2 to the 3x minus 6. Now we have the power property again. I'm sorry, the product property. We're multiplying with the same base, so we add the exponents. 3x plus a negative 2x is x. A minus 6 and a plus 2 is going to be a minus 4. So it's 2 to the x minus 4. This one here, I mean, as far as the directions go, rewrite each expression as a single base. We've done that. But let's apply the negative exponent property to this, just because I'm telling you to. So different ways you could go about this. One is we could kind of work this out backwards, and we could factor a negative 1 out of the exponent. Then we could treat this as a power to a power. 3 to the negative 1 is the same as 1/3. And as far as our work goes for this, we were just demonstrating how this property works, so we're just going to stop there. The directions were poor for that. This next one, the directions said to write it as a single base. We're going to try to follow those directions. We have a little problem here because it's not the same base as these other ones. So how can we fix that? Well, we could rewrite this as 4. Well, let me say that again. We want these bases 4 and 2 to be the same. So I'm going to rewrite 4 as 2 squared. And that's already been raised to the 2x plus 2. So I took 4 and I rewrote it as 2 squared. I did that so I'd have the same base. Here we have a power to a power property. So that's going to be 2 to the 4x plus 4 times 2 to the x minus 1. That's unchanged. And on the bottom, 2 to the 5x plus 3. In the numerator, when you're multiplying with the same base, you add the exponents. It's going to be 2 to the 5x plus 3. The bottom's also 2 to the 5x plus 3. If you divide anything by itself, you're going to get 1. but let's use our properties of exponents to show you how we can still get one just using these properties. Write the base one time on the quotient property. You take the top exponent minus the bottom. 5x minus 5x is 0. 3 minus 3 is 0. Then if we use the 0 exponent property, anything to the 0 power is 1. All right, this next one, lots of different orders you could do these things in once again. I'm just going to work with the inside first. These need to be the same base. I could write 9 as 3 squared. It was already raised to an exponent, so I'm going to put that in parentheses. Power to a power property. I can multiply this 2 times this exponent that it's raised to. And then when I multiply with the same base, I add the exponents. It's going to be 4x minus 6. And then at some point, I'm going to change this square root to a half. Power to a power property, I multiply the exponents, and I get 3 to the 2x minus 3. Property of equality, so these directions up here, wow, they really shouldn't be there. Property of equality says that if you have a single base on each side and they're raised to an exponent, you can set the exponents equal to each other. That's what we have here. We have 3 to an exponent equals 3 to an exponent. Therefore, 2x plus 4 has to be the same as x minus 8. And then it's just simple algebra from here. That's going to conclude this video, which is essentially us just looking at specific examples had to do with these properties.